Alright. We've got Jebediah Kerman piloting this mission to Minmus. And we've got extra struts on here. I've got all the staging set up, hopefully pretty well. I guess we're going to find out. Let's turn SAS on. Watch our charge here. Doing okay because we're not moving at all with all these girders, struts, thingamabobs, stability enhancers that I've got attached to the side here. But let's throttle up. Let's do about 3/4 because I want to be careful about my fuel usage. And I don't really need to use much because these guys on the outside are really going to pack a punch, which I think we're all ready to go. Fingers crossed. We're launching at a fairly good time, I guess. It is possible to launch at such a time where you can just take off and then burn straight for the Minmus or the moon, or another planet, a certain time of day. But we're just going to do a very basic, very simple, step-by-step mission to Minmus here. Something achievable, something you can try at home. Permission granted to try this at home. Anyway, enough goofing around. Let's launch in 3, 2, 1. Aw, yeah. Look at that. Very, very stable so far. Kind of pulling off to one side. Why are you pulling off to one side? Why? All your rockets are going. That's the thing. Okay, so that's the thing. I think it's just the solid rocket boosters. When you put them on a craft, they tend to want to pull to one side. I mean, it could, with all the shenanigans that I did, it might just be off-center, but solid rocket boosters I've found really want to pull to one side. Alright, those are clear. Wow, at the next stage. Fantastic. We are going way too quick for this low in the atmosphere, but so let's turn our rocket engines, our liquid fuel way down. Way down. Yeah, these 4 boosters are really, really socking it to us. Let's regain some control. Oh, it's turning ever so slowly. It's fine. Alright, so I think I've said previously, alright, kill those. Throttle up all the way. Okay, much better. Yeah, so as I've said before, there's atmospheric drag. So at certain altitudes, you don't want to go too fast because then you're just wasting fuel while you push into the atmosphere and it resists you. So here, I should have stayed under 200 while I was below this, but it was close enough. It was close enough for government work. And we're in the second part. I'm doing a full burn, and I'm going to start to turn over here. And we'll get a nice little arc going. Alright, let's check our map view by hitting M. How's this doing? Apoapsis is already at 55. That is very high, so let's turn over a lot more. I'm going to throttle down quite a bit. Yeah, like I said, this rocket is way, way overpowered for what we're doing here. Way overpowered. So we are going. Enough said. What was it now? Oh, 100. Let's just cut it. We're just gonna oh, we've only got a little bit left. Let's burn. Burn horizontally. Okay. I think... Alright, let's cut that. I think we can cut these now. Is it? Yep, there we go. Oh, little bump. You're fine, you're fine. So I've still got some fuel left in this center one. Ooh, this thing is so hard to control with just that tiny pod. I'm just gonna... we might bring it around. I don't know. I don't think it's quite worth it. Let's just head towards the horizon, and we'll be okay. To just burn this little bit of fuel that's left. Burning towards the horizon basically lets us get more length to our arc. So going straight up and down obviously makes us go straight up and down, and going horizontally makes it a much wider arc. So we're going parallel to the planet. There we go, cleared. I'm gonna cut fuel, kick those guys off. Yeah, there we go. So I was hoping to save this fuel to go from Kerbin to Minmus, which I probably could have had I been paying better attention to when I was launching. Man, those solid rocket boosters, they really packed a huge punch. They got us way, way up. But let's head up to our apoapsis here. Warp a little bit. Let's get about 15 seconds out. That's good. Switch back here for now. And we'll start burning with all three of these. Tons of power. Actually gonna kick it down a notch so we can save fuel. You know, I don't actually know if that saves fuel to be not at full. Because you're in space, so you gotta think like, hey, why wouldn't the full thrusts be there? Because you're in space, so there's no drag or anything. I don't know. Someday I'll find out. But let's point up a little bit. I think this will get us there. I hope this will get us there. Might have to launch again. We'll see. We'll see. But this should get us into a orbit very nicely. Okay, I'm just gonna burn at full power here. Now, kind of see I'm going up a little bit above the horizon mark. There we go, and a bit more. A little bit more till we hit 70, and 80 is good. That's good. 120 over here. Yeah. What an ugly orbit. That's okay. We are there. We've got about half our fuel left. We've got the moon here. We've got Minmus here. So you can left click and set it as target or unset as target. And let's talk about these little new tags that we've got. This is the descending node and ascending node, and this does not mean where you should go up or come down as far as orbitally, like going out is not the ascending node doesn't say you need to ascend to Minmus here. All it's saying is in, how do I describe it? So as I'm going around the Kerbin here, I believe this is the low point. Is that right? Well, ascending and descending. You know, I forget what they mean, but basically, these are the points at which our current orbit lines up with the orbit of Minmus all the way out here. See, it's a straight line that goes straight through Kerbin, right? Boom. Done. So, you can see, let's zoom out again. So you can see that moon is, I got rid of the umlauts. There's no umlauts on the moon out here. Fascinating. So moon is actually level with Kerbin at 0 degrees. But Minmus up here is way out, I guess. 6 degrees, perhaps. Yeah, I mean, we got a pretty equatorial orbit. So it's about 6 degrees off. So in order to meet it up here or down here, we would have to change our orbit at one of these nodes. So basically you would, as you approach the node, you would burn up towards north or down towards south. And what that would do is basically if you burn north, then it's like trying to shove you this way. So this side of your orbit would come up much further. So you've got a lot better leverage here than out here. Because if you try to burn from here and you go north and you're trying to go, 6 degrees, then you're going to be burning a huge amount. But you can burn just a little bit out here at the node, and that'll change your orbit much easier, at much better fuel cost. So let's since we want to get out to Minmus, let's try and see if we can do just that. So I'm going to drag this guy out. I don't know if I've talked about maneuver nodes before. Let's take a quick minute to talk about maneuver nodes. Maneuver nodes, they allow you to pre-calculate your burn time and burn direction. Very helpful. You can left click on your blue line wherever you're at. You click add maneuver. Then these 6 icons, yeah, I guess they're icons, will pull or push your orbit in a different direction, faster and slower. If you pull out, it'll go slower. See, I'm going back into the Kerbin here. If I go this way, it's going faster, and so I can fly on out to Minmus. If it goes away like this, you just have to mouse over it until it gets big, and then you left click and it'll reappear for you. So the triangles allow you to change, I think it's called your inclination, but you can change this ascending node. So if I go up, like I was talking about, so we're heading north now, you can see this ascending node gets down to 2.5, meaning that we are almost in line. Oop, see how it flipped there? Once it flips, we are in absolute alignment with Minmus. So at ascending node of 0.0, there's actually a point at which it'll say not a number because it is so exact, but 0.0 is very, very good, because now we will be in the same orbital plane as Minmus here, so it'll make it matching up a whole lot easier. So for example, let me explain why it's easier. As you come straight out here, if we remain in our normal orbit, we will just have one very small point right here at which we could have an encounter. A point at which we will meet the gravitational force of the planet. But as we change, let me get our orbit out here. Oh, far. Bring it in. Bring it out. Okay. So as we get our orbit to change, you can see it's slightly off. That'll allow us to kind of meet the planet at anywhere in its own orbit. The moon, I guess. Meet the moon at any place in its orbit. So let's jump out. Ooh, look. See? Target position at closest approach and closest approach. Yes. So let me get back to these two things real quick, and then we'll explain it. So these are kind of burning away from the planet, and these are burning towards the planet. And what this will do is it'll shift your orbit left to right on the plane that it's at. Like so. You can see we kind of shift it out that way. And then you can even take the same one if you want to be a bit more sensitive and precise. You can actually drag it towards the center, and you can see it's changing much more slowly than if I dragged this one out here. We get a lot of change, right? So let's back this off. And this can be helpful for dialing things in. Usually you won't have to use it, but boom, look at that. Look at that. A Minmus periapsis of 303,000 meters. That is excellent. Excellent. Let's see what we can do to make that better. Yeah, see, look. The thing that I've learned about... Oh, what did you do? It's, okay. So sensitive. The thing that I've learned about setting up these orbital maneuvers is that... Oh, man. Can you... What is going on? I don't know. The more the orbit changes, so you can kind of see, like, as I approach, like, yeah, it does some minor changes, but as we get right on it, very, very close, is when the gravity is going to grab hold of us, and it's going to be the biggest, yeah, like this. So I bet we're really close. Yeah, 14,000 meters. Way, way better than 303,000. So that's because we're so much closer, the gravity's really going to grab us and going to take hold. See if I can get a proper zoom here. Yeah, you can see we're going to come in just above, and then whoop, it's going to loop us down, and we'll head back around Kerbin. Fascinating stuff, these orbital maneuvers. But let's play around with this one a little bit more. I don't know. So the thing with one final thing about these maneuvers is that when you mess around with the blue ones to go towards or away from the planet, if you go towards the planet, it will change your periapsis, and you may end up going through the atmosphere, which is not good, because then you'll slow down a whole ton and you won't make your maneuver. These do not calculate for aerial, what do you call it, atmospheric resistance. So be careful, be very careful. So this one, you can see I'm fine because it goes all the way out, but if I was to do, let's just do it. So if I was to do this, my new periapsis, let me get a good example. This is 55,000 meters, so this is well within the atmosphere, but it's not going to calculate it for me and saying that I'm going to slow down and crash. It's still going to say that I'm going to escape Kerbin's gravity. So let's reset this, put it on our descending node, just so that we are at 0, 0. Let me get an orbit kind of out there, and nope. line adjustment here. There you go, 0, 0. And let's get a nice burn. And as you can see, when I... Here, let's go down. So as I burn this, because these ascending and descending nodes are very sensitive, as I'm going out, I'm actually kind of creating extra force north or south. So they're gonna kind of move around a bit. So if you set it up here, like I got 0, 0, once I get all the way out to min-miss encounter, you can see that I'm at 0.2. So I can adjust these even more. Let's see, 1 and 0, 0. So this puts me at 0, 0 when I'm all the way out at a very close approach. And look at that, we can slow down, and our orbit does not get nearly as wonky. That's much better. Is that good? Let's see how close we can get. Yep, very sensitive. That means we're very, very much right on it. Oh, there we go. We are crashing into the surface because we no longer have a periapsis here. So we are going apoapsis, encounter, sucked right into the gravity well and into the planet. Can we get a good shot of that? Yep. Boom, right through. So this is good in a way because it'll let us get out there and we'll be certain that we're going to hit it. But at the same time, it costs more fuel because we're going to have to make a maneuver somewhere out here at our apoapsis when we're moving super slow to be able to miss hitting, striking the planets directly. Planetary body, the moon, secondary moon of Kerbin. So the other thing, let's talk about orbital maneuvers. So this, as you can see, sure, I'm getting all the way out here and I get a great encounter, but my apoapsis goes out beyond the orbit of min-miss, which means that I'm expending the extra fuel to get that much further out. So ideally, we would want to have our, see, we got our Kerbal apoapsis on the maneuver to be 46 million meters, and this has an altitude of 46 million meters. So we want right about there. So we could even take it in a little bit less, 45 million, so we're a million out. And this means that we spend the least amount of fuel to get there. More fuel to go out further, less fuel to go in further, right? Oh, it looks like I passed my node, so let's set up a new one. There we go. Get out there and adjust. Oops, too far. There we go. Boom, and we'll adjust this guy. Yep. Oh, look at that. Gonna work out really well. Do it. Man, you can spend hours messing around with these, by the way, just to get the perfect situation. What do I want? It's a thing too. It's like it's so hard to tell what direction. Okay, so I need to go way this way. Let's go out, in, up. It gets a little bit crazy. All right, let's bring it in. Okay, so we got our ascending and descending nodes. Go. Gotta have them equal, so 0, 0. Closest approach is a good distance. Let's get it a little bit further out. I don't mind. And okay, so now we're at a good distance out here. We're gonna meet everything just right, but the problem is target position at closest approach. This is where min-miss is gonna be when our ship is out here at our closest approach. So what we need to do is either move our orbit so we're over here when min-miss is coming by, or we can adjust it with the blue guys to kind of shift it left or right. So to change where the burn is in your orbit, you highlight the center circle. You can drag it around. See how we're getting closer? Boom! Look at that. Gotta be a real good one. What was that? 419,000. Oh. So you can drag it, click it, and drag it around. And the thing is, you want to stay on your ascending and descending nodes if you're adjusting your inclination, just because ends up being a whole lot easier and much more efficient. Let's go. Okay, so that's the big point in the orbit. Let's get it here. Alright. Bit far. Let's bring it a little closer in. Alright, let's check our distance here. 46 million. 46 million. Alright. We're at a good distance, so I don't have to mess with the green ones. Let me mess around with the pink guys. 0.5. Let's bring it down to 0.0 if we can. May not be possible. Yeah, 0.6. So these guys are in a good spot here when they're directly across from each other, just like in an orbit. And the reason that adjusting these is not adjusting this is because this maneuver is no longer on our ascending or descending node. So instead of adjusting my plane to match this plane, I'm now adjusting over here to match like a plane over here. If that makes sense. It's kind of complicated, but trust me. Just trust me. It works out. So let's see. So that doesn't work. So we can adjust our node. Okay, can we? What's going on? Oh, come on. Okay. Sometimes it'll try and go away like that, and I don't like it when it does that. Let's use the blue guy, get a nice alignment going on. Okay, let's do this. You can see that we are up above. Let's go down. Do we want to go down? I can never tell. Let's just get a nice close approach, and we'll go from there. Dialed. Nope. I had a much better one earlier. Can't bring it back. And that there is our biggest difference. Make it bigger. I think our node. Let's get back to our node. So we get rid of this. Alright. Final maneuver. Final maneuver setup. And then we'll actually make our way out there. Okay, so we got let's adjust this. It's going to add some extra delta. Delta is another word for force or thrust, the amount of energy which it takes to get out there. 46 million is excellent. Let's adjust that way. Boom. Have an encounter. Let's make it big. Crashing into the planet. Excellent. Let's back it off just a little bit until we're not hitting it. 37,000 meters. Sounds like an excellent orbit. Let's plan on doing that. Okay. So now that you've got your orbital maneuver set up, this is how you do it. So you look at it and you're like, hey, that's good. I like it. Let's go. So you'll loop around. Here's your ship. You loop around in your orbit, and let's just do that since we're up in space. And you've got what, 2 things to look at? I think 2, maybe 3. So the first, let's get around to here so we can get set up. The first is going to be this number here. This is the amount of thrust it's going to take, and this bar will go down. You'll see when we thrust, this is how much force and amount of time it will take. Sorry. So this is let me explain to you. This is the amount of thrust, right? Then down here we've got an estimated burn time of 24 seconds. So 24 seconds, you think, okay, node in T minus blank as soon as I hit 0, boom, we're gonna burn for 24 seconds. That might work, but you actually might miss a very precise burn if you do it that way, because you're gonna hit the node, which is this guy right here, which is kind of the midpoint of your burn if you think about it. So if you start to burn here and you finish burning here, then right in here is your butter zone. Like that's where everything lines up, and you want all your, if you could do it, you could have all 24 seconds occur in this one spot. But since you're traveling, you want to divide it in half and then make sure that you start halfway through. I think I think that makes sense. I know that's how it works. I think that makes sense. We're gonna do it in practice right now. So we've got a 24-second burn. I don't know if I've got enough fuel to do that, but we'll try. Our orbit speed we don't care about, so we got the 24 seconds, we got this, and then the final piece is we need to find our little blue marker. The blue marker is the marker from the maneuver node that tells us what direction we want to go. So this little pink guy is retrograde of our target. So it's when our butt is facing the target, it's over there. This is our butt right here, our retrograde marker. Got the target marker here. Let's slow down our rotation. So we got the target marker is this round pink one, and then our maneuver is the blue one. Point at the blue one. Hear me? Point at the blue one. Alright, so I'm using WASD to move this thing around. Then when I'm happy with where it's at, I'll tap F, which turns SAS off and back on. And that kind of does like a quick little reset so that it's like, okay, I'm not going to try and pull where it was. I'm going to pull to right here where I'm being set up right now. Alright, so we've got 3 minutes left until our node. And we've got 24-second burn. That means we need to do we need to start 12 seconds before we hit our node. So let's speed up a little bit. Not too quick. You don't want to bypass it. In maneuvers inside Kerbin's sphere of influence, so to the moons, it's okay to kind of be a little bit off, but on interplanetary burns, you really want to hit it on the nose as much as possible. Alright, so I'm burning full thrust. Yeah, I think we're going to make it. So you can see as we're burning, this is decreasing. Lets us know how much power, thrust, meters per second we need to gain in order to hit that. Oh, we ran out of fuel. Alright, we're going to stage and burn these. Back to the map. I did not anticipate that. If I did anticipate that, I would have started burning earlier to account for the time difference. So this is our lander fuel, but these engines are extremely efficient. Oh, and we bypassed it. We bypassed it. Did you see that? That purple line that flew by. That was it. That was where we wanted to be. What we can do is we just turn around and burn the exact opposite direction in order to get back what we had. Oh, that was just a Mooner encounter. No! No! Give me that Minmus encounter. Okay, let's burn here. And... alright, here it is. Do we have any luck? We have luck. Yes! Excellent! 90,000 meters. Fantastic. Alright, let's hold it here for just a moment. I'm going to check the time. I'll probably call it an episode, or maybe this is already 2 episodes, but give me just a moment and I will be alright back.